Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm asking, when things hang, why do they always hang down? By the end of this episode, you should be able to tell me what do I mean by centre of mass and what can we say about the centre of mass of an object if it's suspended from a fixed point. So let's start by looking at this Formula One car here. And one of the things you'll notice about the car, one of its characteristics, is that it is an extremely low car. And what that does is act to keep its centre of mass extremely close to the ground. So what do we actually mean by centre of mass? Well, obviously the mass of any object like this car is actually distributed all throughout the object, but what we can do is think of the weight of the object as actually acting from a single point, and this point we call the centre of mass. So we can actually define centre of mass as the point at which the mass of an object can be thought to be concentrated, and that's our official definition that we need to know. But what has that got to do with things swinging and coming to rest? So check this out, when I let it go, you know it's going to start to swing, and you know that eventually it's going to come to rest directly underneath the pivot point, which in this case is my hand where I'm holding onto the piece of string. But why is it that it stops here? Why can't it stop anywhere else? Well, when an object, or in fact the object's centre of mass, is located directly underneath the pivot, which in our case is where the string is touching my fingers, then there is no turning effect on it. If you think back to the calculation we've met before, which says to us that the moment or the turning effect of a force is equal to the force multiplied by the distance, we can see why that is. Because in the case of my ball here, I've got the downward force of gravity acting straight down there. So I've got a force, I've got a force in this equation here, but the perpendicular distance, remember the perpendicular distance is at right angles to wherever the pivot point is. There is no perpendicular distance, it's directly underneath the pivot. So the force of gravity is acting straight down, but the perpendicular distance from the pivot is 0. So we've got a force multiplied by 0, which gives us a 0 moment. There's no turning effect of that force. And it doesn't matter how big this force is, if the distance is still 0, this is going to be 0, so we get no turning effect and my object doesn't move. But if my object is either here or over here, we've still got a force of gravity acting downwards on my object, but now we've also got a perpendicular distance from the pivot point. So now we've got a value for the force and a value for the distance, so we've now actually got a moment or a turning effect of the force, which turns this thing and makes it swing in that direction. And of course it's exactly the same thing over here. We've got a perpendicular distance there, so we multiply that distance by the force of gravity and we get a turning effect in that direction. Only when the object is hanging directly beneath the pivot there is this distance 0, therefore the moment or the turning effect is 0 and the thing just swings straight down. So when we release a freely suspended object, it will always swing due to the turning effect of the forces until it comes to rest underneath the pivot point. So if I release any freely suspended object, what it's going to do is it's always going to swing and it's always going to return to what we call its equilibrium position. And where is that equilibrium position? Well, it's when the centre of mass is below the point of suspension. So that's everything we need to know about centre of mass for the moment. We are going to come back to it later on when we talk about stability, but any problems with what we've done so far, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.